In section 2, we're going to talk more about transformations of the sine and cosine functions, and we're going to spend a little bit more time talking about phase shift on transformation. So if you recall from section 1, the phase shift is when the sine and cosine functions move left or right. And again, when we later talk about like tangent, the phase shift doesn't change. It's still for tangent as well. But for us, we've so far only talked about sine and cosine. So a phase shift is when they move left or right. If you remember, a negative phase shift moves the graph left, and a positive phase shift moves the graph right. So we're going to spend some time looking at examples where the graphs have phase shifts and how to write the equation of a sine or cosine function that does have a phase shift. So if you remember from section 1, the sine and cosine graphs, their general equations are y equals a sine of bx minus c, or y equals a cosine of bx minus c, where the amplitude is the absolute value of a, the period is 2 pi over b, and the phase shift is negative c over b. And if we put a negative sign in front of the function, it's going to flip the function about the x-axis. So negative in front is a reflection. And again, this is just a restatement of stuff from section 1, so it is not new information. So let's go ahead and do some examples where we sketch graphs that have a phase shift. So we want to graph the function y equals 2 times sine of 4x minus pi. And it's going to be very important that you pay attention to the fact that each grid line is the unit pi over 12. And that'll come into play when we finally graph the function. So we're going to go ahead and use those, use the directions from section 1 helping us graph the function. So we're going to start with finding the period and the phase shift. So for our function, the period is going to be 2 pi over b, and in this case b is 4. So it's 2 pi over 4, which is going to simplify to give us pi over 2, which means we can fit one cycle of our sine graph in pi over 2. Now we want to look at the phase shift. So we have negative c, which is negative pi over b, which is 4, which is going to give us pi over 4. So this tells me that our graph has been moved to the right by pi over 4. So these are going to come into play when we pick our values for our table. So when we set up the table for picking our points to graph, we have our angles x, we have our function y equals 2 times the sine of 4x minus pi. So our starting point is going to be 0, and because our period is pi over 2, we know we want to end at pi over 2. So now we have to figure out what angles we're going to pick between 0 and pi over 2. The easiest way to figure that out is just take our period and split it evenly over 4 points. So take pi over 2 and divide it by 4. So that would mean going up by a scale of pi over 8. So I'm going to put pi over 8, then pi over 4, then 3 pi over 8. And these are going to be the angles we plug in for x to figure out our y values. So if we plug in 0, we're going to end up with 0. If we plug in pi over 8 times 4 is pi over 4. And then when we subtract pi, we're going to end up with a value of negative 2. Pi over 4 gives us 0. 3 pi over 8 is 2, and pi over 2 gives us 0. And most of the work where you can get these values, you can use a calculator or Desmos to plug in our value for x into our function to get the y value. So now that I have my points, now I just need to graph those on my graph. Now the issue is pi over 8 and 3 pi over 8 are not x values on our graph because it goes up by pi over 12. So we're going to have to guesstimate a little bit when we go to graph some of these points and figure out where exactly they lie. So we know we're going to start at 0, 0. So I can plot the point 0, 0. We can go ahead and start with pi over 4 and pi over 2 since they're on our graph, 0 and 0. So now we just have to figure out where pi over 8 and 3 pi over 8 are. Well, the nice thing for us is that pi over 8 is exactly halfway between 0 and pi over 4. So we know at the halfway mark, we're going to be at -2. So we can get an idea of that, of halfway being a little bit before pi over 3, which is what this, pi over 6, which is what this second line would be. And then 3 pi over 8 is halfway between pi over 4 and pi over 2. So we want a +2 in the middle there. So now we just connect our points and we get one period of our function. And we can, if we wanted, we could continue sketching this graph to the left and right so we could get more points for our graph. It's going to continue repeating from to the left and to the right. So the next graph we want to look at is y equals negative cosine of 2x plus pi over 3. So again, we're going to start the same way we did in section 1. We're going to identify the period and the phase shift. So our period is going to be 2 pi over b, which in this case is 2. So our period is going to be pi. And our phase shift is going to be negative pi over 3 over 2, which is going to become negative pi over 3 times 1/2, which is the same thing as negative pi over 6. So this tells me the negative pi over 6 tells me we've moved the graph to the left pi over 6. So now we have to create our table of values. So we have our angles x and our y values that come from negative cosine of 2x plus pi over 3. And because there's a negative out front, I know my graph is going to be flipped over the x-axis. So now we have to figure out where we're going to start. And when our phase shift is negative, which means we've moved the graph to the left, we actually can want to start at that phase shift. That would be a good starting point. So I'm going to start at negative pi over 6. And when I choose my ending point, I want my ending point to be one period away from negative pi over 6. And since a period is pi, if I add pi to negative pi over 6, we're going to end up at 5 pi over 6. So I actually want to fit my other points evenly between negative pi and 5 pi over 6. So if I keep adding pi over 6, I will get to 5 pi over 6 evenly. So that's going to give me pi over 12, pi over 3, and 7 pi over 12. Those are going to be my points I want to plug into my function to get my y values. And again, all of my y values I'm going to come from plugging in these values for x, and it comes directly from a calculator. So negative pi over 6 is going to give me a y value of -1. Pi over 12 will give 0. Plugging in pi over 3 will give 1. Plugging in 7 pi over 12 gives 0. And plugging in 5 pi over 6 gets -1. Now we just have to graph these points to get our picture. So And the nice thing for us is each unit is pi over 12, so it's going to be easier to graph our points. So at negative pi over 6, which is the same thing as 2 pi over 12, we're going to put our first point. So at negative pi over 6, we're going to go to negative 1. Then at pi over 12, we're going to be at 0. At pi over 3, which we're going to be at 1. At 7 pi over 12, we're going to be at 0. And at 5 pi over 6, we're going to be at negative 1. And now we just have to connect our points. So we get one period of our graph, which again, if we were to continue in either direction, again, this is just a sketch for either direction, we can get a continuous graph of our function. One last example, we want to sketch the graph y equals 3 cosine of negative 2x minus pi over 3. So start off with the period and the phase shift. So the period is going to be 2 pi over, in this case, b is negative 2. So that's going to give us a negative pi. A period can't really be negative unless we were talking about going in the left. So we can also consider our period to be positive pi. If you think if I'm going to go in the positive direction, I'm going to get the same thing as if I were going to go in the negative direction and get a period of pi. When we do our phase shift, it's going to be negative pi over 3 over negative 2, which is going to become pi over 3 times a negative 1/2, which becomes negative pi over 6. So again, we have a phase shift of negative pi over 6. So it's going to be the same table that we set up for our previous example. So when I set up my table, I have our x and our y equal to 3 cosine of negative 2x minus pi over 3. So I'm going to have the same angles as before, negative pi over 6, pi over 12, pi over 3, 7 pi over 12, and 5 pi over 6. Because my period is also the same as the before, which is pi. So now when I figure out my y values, I'm just going to plug in all of these x values into my equation. So we're going to end up with 3 when we plug in negative pi over 6, 0 when we plug in pi over 12, negative 3 when we plug in pi over 3, 0 when we plug in 7 pi over 12, and 3 when we plug in 5 pi over 6. And then the last step is to graph our points. So negative pi over 6 is going to be at the second line because, again, our units have not changed, and we're going to be at positive 3. At positive pi over 12, we're going to be at 0. At pi over 3, we're going to be at negative 3. Then at 7 pi over 12, we're going to be at 0. And then at 5 pi over 6, we're going to be at 3. So connecting our points, we get one period of our graph, and we can continue that graph to get in each direction. Again, you would want to be more accurate on your graph to make sure that they're lining up. Again, I'm just sketching what it would look for values outside one period. Either use Desmos to get a more accurate picture or plug in more values into your table to get exact points. So just like in the previous section, we can write an equation given a graph as well. So that's what we're going to do for our last two examples. And in both examples, each grid line represents pi over 6, which is going to help us when we're writing our equation. So just like with section 1, if we're given a graph, we have to determine if it's sine or cosine. And as I previously stated, it doesn't matter which one you pick because I can write a sine or cosine function no matter what graph I'm given, since they're phase shifts of one another. But there is going to be an option that is usually a bit easier. So if we're looking at our first example here, if I were to take my maximum point and move it so I was on the x-axis, I would be starting at 2. And I know that my cosine function starts at a positive value. So I'm going to pick cosine of x to be my graph here. So now we just have to identify an amplitude, any vertical shifts, any phase shifts, and the period of our graph. So to figure out the amplitude, I'm going to pick the maximum and the minimum point. So I know that the amplitude is equidistant from the midline. So because my maximum is at 2 and my minimum is at 0, I know the midline is halfway between that distance. So from 0 to 2, I go 2, which means my midline is at 1. So if I draw that midline that goes through 1, that will give me my amplitude as well. So I know that my amplitude is going to be 1. This is also going to help me to determine my phase shift as well. So because I know that the cosine function starts at 0, well, it starts at 1 actually. I know that in order to start at 2 on the y-axis, I'd have to move up 1. Sorry, this is not a phase shift, this is the vertical shift. So I know my vertical shift is going to be 1 as well. So now we just have to figure out what the phase shift and the period are. Well, if I wanted to go from this maximum point over to the y-axis, that would actually represent my phase shift to go back to where I would start on the y-axis. So I have to figure out this distance here, and that is going to be my phase shift. Well, if I look at my scale, this point is halfway between 0 and pi over 2. And using the unit circle, halfway between 0 and pi over 2 is pi over 4. So we're going to know our phase shift is pi over 4. Now all that's left is to find our period. So we have to figure out, if we look at the regular cosine function, the cosine function starts at 1, it travels down to -1, and then it ends back at 1. So we want to do the same type of deal for our function. So if we're going to start at 2, we want to travel down, and then we want to come back up again. So our phase shift, this is the phase shift. Our period is going to be from here to here. So I already know that this is pi over 4. So this point is going to be halfway between pi and 3 pi over 2, which is going to be 5 pi over 4. So I have to figure out the distance from pi over 4 to 5 pi over 4, which is going to be pi. So that tells us that our period is pi. Now we have all of our information to write the equation for our graph. So the fact that the amplitude is 1 and I don't have a reflection, I know that my graph is going to start as y equals cosine. Now I have to go figure out what's in the parentheses. Well, with a period equal to pi, I know that b comes from the period. So we know that 2 pi over b has to equal pi. And the only way for that to happen is if b equals 2. So I know inside my parentheses I'm going to have a 2x. Now we have to figure out c. Well, c comes from the phase shift, which we know that the phase shift is negative c over b. So we know negative c over b has to equal pi over 4. Well, we already know b is 2. So we know negative c over 2 has to equal pi over 4, which leads to the fact that negative c is pi over 2, and we get that c is negative pi over 2. So that means I'm going to have a minus pi over 2, my parentheses. So I'm going to close that out, and at the end, I put the vertical shift, which is a positive 1. So we're going to have a plus 1. And if I were to graph this function in Desmos, make sure that each grid line represents pi over 6, my equation would match that graph. Last example, we want to do the same thing. We want to write the equation for this graph. And just so we have an example of each, I'm going to go ahead and use sine for this graph. It is actually the easiest one as well. So now we want to figure out the amplitude, vertical shift, period, and phase shift, and if there is a reflection. Now, if you remember back to the parent function for sine starts at 0, and then it actually goes up first. And if we look at our graph, if I were to pick a point, it would actually go down first. So this tells me that I have a reflection. It's been flipped over the x-axis, which tells me there's going to be a negative in front. So now we just have to figure out amplitude, vertical shift, period, and phase shift. So if I pick my maximum and my minimum to figure out my amplitude, I have minimum and maximum. So I have to go from my minimum's at -2, my maximum is at 0. Halfway between 0 and -2 is -1, which means my amplitude is 1. It also helps me determine the vertical shift. Because a sine function starts at 0 and it's normally between -1 and 1, in order to be between 0 and -2, we have to move down 1. So I also know my vertical shift is going to be -1. So now we want to figure out our period and our phase shift. So to figure out our phase shift, it actually comes from this point right here. So on the negative sine of x function, we move down 1. We'd actually start at -1. So I know from here to here is going to be my phase shift. And because each line represents pi over 6, I know that distance is pi over 6. So to figure out my period, we're going to use this as our starting point, and with a regular sine graph, with the negative out in front, we'd go down and then back up, and then we wouldn't end at 0 again. So this point is going to be the ending. So from here to here is going to represent my period, which this is pi over 6. And then I'm actually going to, if I end at 2 pi and I go one more than that, I'm going to end at 13 pi over 6. So the distance from pi over 6 to 13 pi over 6 is going to give us 2 pi. So the period is going to be 2 pi. So now we have all of the information to write the equation of our graph. So we have y equals, I know I have a negative out in front, so negative sine, and then we have to work on what's inside our parentheses. Because the period is 2 pi, I know that b is 1, so it's going to be x. Because our phase shift is pi over 6, if we use that to find c, so negative c over b has to equal pi over 6. Well, b is 1, so we get negative c equals pi over 6, which tells us c is negative pi over 6. So we're going to have minus pi over 6 in parentheses, and then we're going to put the vertical shift at the end, minus 1. So if I were to graph y equals negative sine of x minus pi over 6 minus 1, make sure that the scale is pi over 6 on the x-axis, I would end up with the exact same graph that we have here.